Hey everyone, good afternoon. My name is Jonathan Campos and welcome to Tech Talk DevOps Edition. Let's go ahead and get started. So we're here today to talk about monitoring and alerting on your Kubernetes clusters in seconds. We encourage everyone to go ahead and ask questions as the presentation goes along. We'll be answering questions at the end of the presentation, and we're very excited that you are all here. So thank you very much. Real quick introduction for myself. My name is Jonathan Campos, and I am a Senior Product Marketing Manager here at Splunk, and I've been at Splunk here for a little over a year. I am a certified Kubernetes administrator, and I'm here again to talk to you about the great things that we have to offer when it comes to Splunk Observability and your Kubernetes environments. All right, let's kick it off with our agenda. So we're going to talk about Kubernetes, microservices, their strengths versus their challenges, what should I be monitoring, and as well as alerting made easy with Splunk Auto-Detect. And the cool thing about Splunk Auto-Detect is that this is an out-of-the-box experience that you automatically get to take advantage of. So we'll have a demo of just that and then go into Q&A. All right, let's get started. So why is everyone using Kubernetes? It's a no-brainer that you have the scalability to scale up and down when you need it, transparency, time savings, and version control. Kubernetes has really made things so much easier when it comes to go-to-market strategies, getting things scaled to the right point of where you need things to be. Each container does one thing, and you have microservices broken down. And the great thing is that all relation between containers are mapped onto these configuration files. So you can actually bring up your environment from just these configuration files in no time. Now, how it actually evolves is that microservices solves quite a bit of issues and makes things simpler, again, when it comes to agility, where each service is deployed independently. Okay, you have small and focused teams where you have a single team that can build one specific type of environment. Let's say it's a checkout service, or it's an inventory service, or it's a currency service. You have all of these broken down. And you also have a smaller code base where you untangle code dependencies, making things so much more simple to understand for your SREs. You also have a mix of technologies where you can use the right technology for the job. If Node.js is the answer, or if Redis is the answer, or if Cassandra is the answer, you can build these Kubernetes clusters, or these Kubernetes pods rather, to fit the technology that's best for that job. And then you also have my favorite thing about microservices, which is fault isolation, where it's easier to isolate failures and failovers. Your site, your e-commerce solution, your implementation doesn't necessarily need to be completely down if just one service is down. You can still service your customers at 90 or 80% capacity. And then, of course, we've mentioned this many times with respect to Kubernetes and many Kubernetes talks here at Splunk, is that horizontal scaling for each piece as necessary. If you're having a big launch, you can scale up. If you're having just a regular good old day of just regular e-commerce services, you can scale at what you need and consider that also as a major cost savings. And last but not least, the other thing that we want to touch on is that data isolation, where you have data schema that can adapt on the fly without complete data rewrites. I mean, microservices are really helping us go to market quicker, develop solutions faster in a more agile environment. But there are challenges that do come with microservices, starting with resource management. Managing a large environment by hand is absolutely impossible, and you have to keep track of where things are running, which service has a dependency to another service, and so on and so forth. All of this has to be taken into consideration. You also have deployment. There's tens of thousands of services that get deployed, sometimes daily, sometimes hourly. It depends on the application and definitely depends on the use case. Did your deployment make things worse? Are questions you're going to have as an SRE, as a developer. Can we deal with all of the languages, frameworks, and all the third-party code? What was the behavior of someone else's deployment to, let's say, my deployment? All of this comes with some of the challenges with microservices. Now, another thing that we also have to consider is challenges with respect to service discovery. Which service talks to this service? We have a small little graph here on the top left-hand corner where you can see that the checkout service and the front-end service are both reliant on the currency service, right? So it's crystal clear here that each microservice can be scaled up and scaled down based on your needs of your organization, but you need to be crystal clear on how the architecture is broken down, okay? And in this ephemeral world of constant deployment, right, where services, or these containers are going up and they're going down and they're scaled up and scaled down, we have to make sure we have a clear understanding of our services. Now, Splunk Observability Cloud tightens this entire experience together to have one solution for your observability needs. And specifically here today, we're going to talk about Splunk infrastructure monitoring and how it can help you with respect to your Kubernetes deployment. Now, one thing that I want to touch on is that when it comes to our data collection, OpenTelemetry is the standard that we use in parallel with the OpenTelemetry collector. And it's a standard-based agent. You own your data. You're going to instrument your applications once. You're going to make sure that you're using these standards, and you can send this data, okay? You can send this data over to the framework that you choose. And you have support for developer frameworks, and you also, at the same time, can leverage any code at any time. There's many different libraries available for your disposal, okay? So with that being said, okay, Splunk is the #1 contributor to OTel, okay? Splunk is the #1 contributor to OTel. Now, when it comes to Kubernetes, Splunk Infrastructure Monitoring offers 3 main things, okay? It offers 3 main things. First, we use the Splunk OpenTelemetry connector, and that is used to provide that telemetry from Kubernetes to Splunk Observability. You have one collector, and it's deployed with a simple Helm chart installation. You're going to see that live here today as part of our demo. In addition to that, you'll also have the Kubernetes Navigator, which gives you an at-a-glance infrastructure page that allows you to see all of your Kubernetes clusters, if they're up, if they're down, how your pods are performing, what exactly is going on in that Kubernetes Navigator. And the Kubernetes Analyzer helps you troubleshoot your Kubernetes problems at scale by highlighting specifically Kubernetes objects that may be bad. See, what's going to happen is you're going to have all of these environments deployed. We've seen deployments of tens of thousands of different services for X, Y, or Z reason, okay? So we want to make sure that we have the insights that we need to continue to troubleshoot effectively and find that needle in the haystack, okay? So now, when it comes to, all right, so when it comes to the key metrics that you specifically want to focus on, I've highlighted 5 different major points when it comes to the infrastructure and specifically Kubernetes. You'll want to identify pods that are in a pending status. That probably means you have some inadequate resources. You're going to want to scale up your Kubernetes clusters and have more resources for these pods that may be in a pending status. When it comes to pods that are in a failed status, you may have the wrong image used for a pod, the wrong command arguments passed to the pod within your YAML file. And these are things that can be easily oversighted, but quickly tested before deployment. But you want to make sure that before your customers are affected, that you can easily find these problems and quickly take action. Now, as far as containers with high restart counts, applications inside the container could potentially be crashing. And that's something that you want to quickly identify and quickly take note of. Nodes, on the node side, you want to make sure that you have the adequate amount of space. You have the adequate amount, disk space, the adequate amount of memory and processing power. Consider using resource limits when you deploy your Kubernetes pods. You don't want to necessarily deploy a Kubernetes pod and not necessarily identify a specific resource limitation within your configuration file. Also consider taints and tolerances for those particular services that are critical that are critical to your organization. Mission critical services, we all have them. We've all worked with them. There's certain, while all of our services are important to our SLAs, we know that we have certain mission critical services that we can leverage. And Splunk Observability, specifically infrastructure monitoring, is going to help you identify that. Also, if you have nodes that are experiencing, well, high CPU or memory, again, exactly what I alluded to, no pod resource limits, not enough nodes, or potentially over-provisioned resources. So keep that into consideration. Now, how we're going to help you simplify your onboarding experience with out-of-the-box alerting, I want to talk to you guys and show you guys here in our demo, Splunk Infrastructure Monitoring's Auto Detect. It's going to give you a faster time to value with out-of-the-box problem detection for critical components. You're going to automatically, we at Splunk are going to automatically discover these anomalies in your infrastructure, and we're going to quickly identify the infrastructure state and provide an alert for a faster MTTR. Now, don't get me wrong, we're not going to inundate you with so many alerts that you're just going to go insane. These are up to you. You're going to control this the way you, as an administrator, as a Kubernetes engineer, want to control this alerting, because we're going to provide you with that out-of-the-box menu, and you're going to choose what's important to you and your organization based on the actual telemetry that's coming into Splunk Infrastructure Monitoring. Okay? Now, let's be crystal clear here on one thing. Why Auto Detect? Auto Detect recommends these common detectors. Detectors are things that we detect within Splunk Observability that may or may not be bad, and then you, as the administrator, choose if you want to be alerted on that. You can choose a team specifically. You can choose to send this alert to PagerDuty, send this alert to Splunk on Call, send this alert to an email, or send this alert straight to Slack. It's completely up to you. You have the freedom of choice to do so. Detectors are created as soon as data starts flowing into the system, and detector resolution automatically updates to adjust to new data. If for whatever reason we see that no more telemetry is coming in from into Splunk Observability for X, Y, or Z given Kubernetes cluster, we're going to automatically adjust that for you. We're going to make it happen live, and you as an administrator don't necessarily need to worry about that. And alerts are shown on the infrastructure navigators, which I'm going to show you here in our demo. And you, again, have the ability to automatically subscribe to these notifications in the event that you, as an administrator, want these notifications. Now, again, we want to make sure that you guys are keeping those questions coming, okay? I see some questions coming in, okay? And off the top, I want to say, again, if we don't get to all the questions here today, we will be sure to contact you later on with respect to the answer to your question. Now, we'll continue on with the presentation here. How do I get started? What do I need to do to get Auto Detect? Well, it's simple. You're going to configure your Kubernetes cluster to start emitting telemetry to Splunk Observability Cloud. It's that simple. Then Auto Detect begins working. That's it. There's just nothing else to it. Again, out of the box. And that's the beautiful thing behind it. All right? So enough talking. I say, let's go ahead and get to the demo. I think that it's all about seeing this live to really embrace the beauty behind Auto Detect. All right? So I'm going to go ahead and share my screen, and bear with me here for just a quick second. We should all see Splunk Observability Cloud. And what I want to do is I want to quickly break down for you exactly what we have here. So what we have are two terminals. We have one Kubernetes cluster that's running on my Mac and one Kubernetes cluster that's running on my Ubuntu server. Now, specifically, what I want to show you guys is I'm going to do a kubectl get pods, okay? And you'll see that we have a couple of deployments. We have a couple of Redis servers. And you'll see that in this particular Kubernetes cluster, we've already deployed the Splunk Open Telemetry Collector, as well as the receiver, which is responsible for receiving that telemetry. This particular Kubernetes cluster here on my Ubuntu server contains 4 specific nodes in regards to this particular cluster. You'll quickly notice that one of them is not ready. One of them is not online, okay? Which is kind of why you see a couple of these particular pods, or these containers rather, in a terminating state, okay? Over here on my Mac, we also have a Kubernetes cluster that's been deployed, and I'll run a quick kubectl get pods, and you'll see that I only have four different Redis deployments here on this particular deployment. The Splunk OpenTelemetry collector has not been deployed, okay? So we're gonna see how we do that here live on the presentation, okay? So I'm gonna go back over to Splunk Observability Cloud, and in the platform, I'm gonna click on Data Setup. As you can see here, we can integrate with over 200 plus different integrations for your organization. In this case, of course, I'm gonna choose Kubernetes, okay? And what I'm gonna do here is I'm gonna click on Add Integration. Once I add the integration, I can choose the token or the access token that I created here already in Splunk Observability. I'm gonna choose a cluster name, and I'm also gonna choose a provider. Let's take a look at what these providers are. These providers are gonna help with labeling where your deployment is located. Specifically, we have Amazon Web Services, Microsoft Azure, Google Cloud Platform, or if you're choosing another provider or you have your Kubernetes cluster locally deployed, then you would go ahead and just choose other. For your distribution, the same follows: Amazon EKS, Amazon AKS, and so on and so forth. Because this deployment is local to my environment, I'm gonna go ahead and choose other, and we're gonna leave no for the gateway. For the Kubernetes cluster name, we're gonna go ahead and name it KAS Mac, so that it's easy to understand that this is the Kubernetes cluster that is running on my Mac machine. We'll go ahead and click Next, and now we're presented with a series of Helm chart commands. Now, of course, you'll definitely want to install Helm on the machine. You can actually just type Helm to confirm, and you'll see that you'll have a list of commands that you can run. I'll go ahead and I'll clear the screen, go back over to Splunk Observability Cloud, and I'm going to go ahead and copy this first command here that will add the repository to include the Splunk OpenTelemetry collector. So let's go ahead and do that. And in my case, you'll see that I already have this particular repository in place. So I'll skip that part. Then we'll go ahead and copy the Helm repo update command just to make sure that we have the latest updates, make sure we're all good. Successfully got an update from Splunk OTel collector chart, so that looks good, all right? And then last but not least, we can go ahead and copy the Splunk OpenTelemetry collector for Kubernetes command, which will in fact install the actual OTel collector, all right? So all that looks good. We'll go ahead and hit enter. That'll go ahead and install of course, the Splunk OpenTelemetry collector. We'll go ahead and clear the screen to get organized. And then we'll do a watch kubectl get pods. And what we'll do is make sure, and actually it's already been deployed, so we're good to go. You'll see that an agent has been deployed to every specific node in my environment. And then of course we have the receiver that's receiving the telemetry from these agents. I'll go ahead and quickly show you guys that we do have in this environment, we actually have 3 particular nodes in this cluster, our master node, of course, and then our other 2 worker nodes. So nothing crazy, nothing out of the ordinary, okay? Let's go ahead and go back into Splunk Observability. We'll go ahead and click Next. We're actually not interested right now in viewing logs, so we're gonna go into infrastructure. And then under infrastructure, you're gonna see over here on the top left-hand corner that we have Kubernetes. We'll go ahead and click Kubernetes. We'll go ahead and filter this data out to 1 minute. All right, and we can see that we have some past, of course, clusters that we used to use in this environment that are actually not emitting data, but we can easily filter out for our cluster. So in this case, I'll choose KAS Mac, okay? So that's that, and we can easily see here that we now are presented with our Kubernetes map, okay? And this is great here. Let me go ahead and select the Kubernetes cluster, okay? And you'll see here, actually, you know what I'm going to do is let me break down here the nodes, first of all. So you can see a quick breakdown, and we'll go back to the map in just a second. But you can see here that the amount of CPU being used for each one of our given nodes. We can see, again, a simple breakdown of the CPU used, memory used, the disk that's used, network, host cores, total memory, and the condition, whether ready or not ready. We can also see our workloads, right? We also have, of course, the ability of filtering by namespace. In this case, I only want to see the workloads I care about in this case, which of course are my Redis clusters. So I can go ahead and choose default, and I'll see that, okay? In this case, we're still waiting for data to be emitted here, so we will eventually see that come in, okay? We also have our node details, right? So we can easily see some charts that easily break all of this down. And if we actually go back over to our workloads, let's just make sure. And again, we want to make sure that data is coming in. So it does take a second to enumerate and populate. So we'll see those Redis pods there in just a second. But we'll see over here under our node details, we actually do see that there. So we're receiving that data effectively. Here are our Redis pods there, as well as our collector. And again, we can select each and every one of them. We can filter by specific node name. If we want to just look at all of the pods that are specific to this particular node, we can do that and make it as easy as possible and filter it to our needs. Also, our workload detail. Our workloads, of course, are containers, and we can see a breakdown of all of that there. And again, I want to emphasize that not all of the data has come in yet. It'll take about a good 2 to 3 minutes to get all of the data start to show in Splunk Observability. Then, of course, our pod detail will break that down, and we can see, again, detailed information with respect to all of our pods in the environment. If we choose to filter by node, if we choose to filter by pod, let's just say we want to only look at the Redis 2 Mac pod in specific and see how this particular pod is performing, we can do just that. And then, of course, we also have our container detail, right? So with that being said, I want to go back over to the Kubernetes cluster map, okay? And we can see that broken down here. We can highlight and actually view all of our different pods that are available. All of our workloads are ready to go. We can see a couple of our Redis pods that are here on this particular node, which is Minikube M02. We can see here as a quick high-level overview all of the other pods that are deployed in this particular Kubernetes node as well. If we click on the top left-hand corner here, okay, this will bring up the analyzer. And the analyzer, in this case, for this particular environment, since this environment is solid, it's up and running, we don't have any alerts on the top left-hand corner. This is just an analyzer analyzing this environment, kind of looking for problems and bringing it to light for you, right? Making you aware of what's going on. If you actually select on one of these particular, let me close this here. All right. If we actually select on one of the specific nodes itself, we can actually get some info or some detailed information. We can also open this up here, and we can go back into that main screen. But let me go back. Okay. And again, in particular, we're looking at Minikube M02 node, and we can scroll down and we can see just, again, a quick overview of what's going on here if we choose to. We can go over to the analyzer, and once again, broken down, filtered down specifically to this particular node, we can see if we are in fact having some high memory issues, if any nodes aren't ready for this particular environment, and so on and so forth. So again, we're constantly analyzing for you to see just exactly what's going on. Now, one thing that I want to highlight here is when we go over to our Ubuntu Kubernetes cluster and we break that down, we'll see that we, in fact, have one particular node that is not ready, right? And we spoke about that, and that's actually highlighted by this gray block that you see here. And what I want to do is just go back, just to remind you guys that Minikube M04 is in a non-ready or not ready state, okay? So it's not a good thing if this was actually, in fact, in production. So we would have a breakdown. We would obviously see that the node condition, there's no data coming in. Obviously, there's something going on. So naturally, we would want to be alerted on that, right? So what we're going to go ahead and do is we're going to go to our alerts and detectors, okay? Now, you can quickly see here that we've had some issues already occur. We actually have some active alerts. This is what our out-of-the-box experience brings you. You'll see this auto button that's right here, okay? And this particular auto button highlights the fact that we're just recommending some alerts. We're recommending these things, and if you know what, honestly, if this is a test environment and you're just not interested, easily go ahead and resolve it, or go ahead and create a muting rule so that you can automatically alert any alerts that are coming in from this particular cluster, okay? If you are interested in any one of these alerts, you can easily subscribe. But let's show you the breakdown. So you're going to start with your detectors. You can quickly see that we've detected here on Splunk Observability that, in fact, there's some stuff going on with respect to the Ubuntu server, the Ubuntu cluster having some issues. We could see that some of them, again, are scheduled and have not been deployed. And in this case, we can actually highlight, and I want to just dive deeper here. And actually, let me go back, okay? We can actually dive deeper here, and we can see that, in fact, the Minikube M04 node itself is in a not ready state, okay? So we're proactively seeing out of the box, just in fact, that one of our Kubernetes nodes are not running. Something is definitely going on. And we, as administrators, if we choose to, we can resolve it, okay? Or we want to definitely dig in further, and we want to see what's going on. And I also want to show you as well where, in some cases, we have a high restart count of quite a few different pods within this environment. Again, completely out of the box. I've done nothing to configure these alerts from me being aware of these particular detectors. These detectors are coming to me out of the box, and again, zero configuration has been done. And now if we go over to our active alerts, if we choose to subscribe to one of these alerts, we can select that. We can see the details behind this particular alert, and we can easily subscribe to them. Or, you know what? This is a test environment. I'm really not interested in it. Let me go ahead and just resolve it. It's cool. I don't need to know about this anymore. This particular pod, as you could see, it looks like in this particular case, the value of this is outside of zero, meaning we've had an alert. I can easily go ahead and resolve it. I'm not interested in this. No problem. Okay. Again, these detectors, we can also, again, manage subscriptions and subscribe to these particular detectors. So in the event that the detector creates an alert, which is over here okay, we will then be notified. So I can easily come in here, I can manage subscriptions, I can add a recipient, and I'll go ahead and add my email, or if I want to add a particular team, I can do so. If I want to integrate this with Slack, I can do so. But in this case, we'll keep things simple, and I'll get some alerts. Why not? Let's go ahead and do that. I'll go ahead and update. I'll go ahead and close that. And now, as an administrator, I'll be receiving emails with respect to any alert in the event that a daemon set is ready versus scheduled, and so on and so forth. And we can see that these alerts have happened and have cleared, and they're happening over and over, and we can start to dig in a little deeper. Now, let me go ahead and delete that before I get tons of emails a little later, okay? Actually, I'm just seeing a few emails come in right now. So with that said, again, we can also, if we choose to, okay, and let me just clear this up right here, okay? We can actually choose to group this by a particular cluster name, a particular namespace, a particular node name. Say, for an example, we're only interested in M04 particular alerts. We can do that. Again, we want to make sure that it's specific to you. And then I know this particular talk is specific to infrastructure monitoring itself, but if we actually choose to obtain some APM filters, we can also add those filters there as well. So in summary, again, Splunk Observability Cloud is helping you, okay, get alerted out of the box, allowing you to quickly see exactly what you need without having to do a lot of investigation, a lot of work, right? Again, out of the box experience, we see that Kubernetes map, making it easy for you to understand just what's going on once you start to emit telemetry, getting high level overviews with respect to your nodes, with respect to your workloads, okay? and so on and so forth. Again, there was nothing specific configured here to make this happen. We saw specifically, and we'll go back to, let's say, my Mac cluster. All of this data is coming straight from Splunk's Open Telemetry Collector, and it's sending this data to Splunk Observability Cloud. All right, so let me go ahead and end my screen sharing here, and you should start seeing my presentation now, okay? And we're gonna move over to our additional resources. So in order for you to have, again, just have some more information with respect to Splunk Observability and continue your Splunk journey, we have some additional resources here that are available for you, okay? And we have our 12 immutable rules for observability to make sure that you're really getting what you need specifically for your observability deployment. Some observability videos and concepts that we have put together. It's a bunch of great videos showing you some walkthroughs, as well as some step-through Splunk Observability Cloud product walkthroughs that you can take advantage of. So if you don't necessarily have a trial, while we do highly recommend that you do have a trial in place, okay, and definitely test this out for yourself, you can actually do a step-through product walkthrough, and I definitely recommend that. It'll give you some good interaction with respect to the UI. And of course, some general information on Splunk Observability, which is Splunk Observability, observability.splunk.com. And last but not least, a quick link to our free trial. We highly recommend that you try this out, get to know your Kubernetes environments. You can set one up fairly quickly with Minikube, just like I did. I highly recommend Minikube. It's very easy to set up, very easy to download, and there's tons of documentation if you want to get more familiar with Kubernetes and just really test things out with Kubernetes. It's definitely a fun tool to try when testing Kubernetes. And you'll definitely also want to continue the conversation on community.splunk.com. In our community page, we have all of our Tech Talk recordings, 1, and 2, we also have a great discussion panel and a great discussion board where we can talk about different DevOps concepts and different DevOps talks, among other subject matter with respect to Splunk. So Splunk Answers is a great place to check that out, as well as the discussion labeled Tech Talks. Definitely check that out and search and vote and request for enhancements and solutions for some of our products. So if there's something there that you specifically saw that you're probably interested in seeing and you want to definitely put an idea in or vote for an idea, you can definitely do that there on our community page. Okay, one more quick announcement is that .conf 22 is also coming up. We're actually going to be in person as of now, as well as virtual. Okay, it'll be at the MGM Grand in Las Vegas, Nevada, June 13th through the 16th, and virtual on the 14th and the 15th. Definitely a fun event. I'll definitely be there and hope to see you there. And we're going to talk tons of observability, tons about all of our products. So it's a very, very exciting event. We want to make sure that you're aware that registration is open and it's coming up. All right. And then last but not least, we're going to stop over on Q&A. All right. So let's break some questions down. All right. All right. So we've got tons of questions here on the queue. So I'm going to go in order. All right. So the first question is, can we use OTel for Splunk Enterprise on-prem? No. This is specifically for Splunk Observability Cloud. All right. Where are these installed? So I'm assuming that you're speaking of the agent itself. The agents and the actual receiver are installed on the Kubernetes cluster itself. On the Kubernetes cluster itself. Okay? So I hope that helps answer that question. All right. Does Splunk Open Telemetry Collector work with Splunk ITSI? Are there ITSI content packs that create KPIs? Yes. So there are content packs that you can use within Splunk Observability Cloud. So you can actually emit your data or send your data from Splunk Observability Cloud over to ITSI. That is an absolute yes. All right. The OTel collector is a function equivalent. I'm sorry, I'm just reading through this. Oh, here we go. Is it possible to alert on Kubernetes problems, problem events like disk pressure and memory pressure? Absolutely. Are they metricized? Absolutely. You absolutely can do it. Absolutely can do this. Okay? Absolutely. Is it accurate that there should always be a resource limit defined? Now, this specific is to Kubernetes, and my answer to this question, I almost want to say yes, you should. You definitely don't want to, I mean, if we're testing, right, let's be completely transparent here. If we're testing, yeah, you're okay if you want to kind of understand just specifically what's going on with respect to how this particular pod, what this particular pod needs or what this service needs, then yeah, you're definitely trying to gauge a specific breakdown of what exactly it is you need to allocate for this given service. However, in my opinion, when in deployment, we definitely should add resource limits, in my opinion. Again, there may be some minimal use cases as towards why we don't necessarily need resource limits, but I highly recommend them, definitely. All right, the next question. Let's see here. Looking through these questions here quite a bit. Can we clone the auto detector and customize it? Absolutely. So I encourage you to definitely bring this up in our community page. Sorry about that. Bring this up in our community page. And but there is tons of documentation on customizing specific what we want with respect to the auto detectors to come into place, right? So we have tons of documentation on our docs page, but if you want to use these as a template, you absolutely positively can, and then customize them to fit your needs. All right, so I hope that helps. Okay. How about logs and monitoring? So yes, we are working on that. Just looking through these questions, we have just a few, and forgive me, we actually do have a few redundant questions. So I definitely don't want to answer them if we've already done so. All right. Yes. Okay, so are the links supposed to be clickable? Yes, they are. Absolutely. You can click the links. And another great thing that I would like to emphasize with respect to the links is that you can easily share them. If you have a detector, if you have an alert, you can actually quickly share them to a colleague or a contractor for more investigation on this given alert. Absolutely. This is a great question that we do get, and I want to make sure that I emphasize this. All right. How do we download the slide deck, and how do we get more information? This is going to be emailed to you in a follow-up email. This entire presentation, as well as this particular recording, will be available for you to see on demand. So you'll be able to see that there. All right. So again, we did answer that question. Again, just going through the questions here, we have quite a bit of questions here. So we want to make sure that we don't answer the redundant ones. All right. Just going through these questions here. So we have gotten this question quite a bit. Is this only on Splunk Cloud? So we have Splunk Enterprise, Splunk Cloud. This is actually Splunk Observability Cloud. All right. So we have a couple of other questions. Okay. When is auto detect for out-of-the-box alerting enabled? So this is going to be deployed to your Splunk Observability Cloud environment. This is again going to be readily available at your disposal, okay? Will administrators be alerted from every recommended detector by default? The answer is no. You must subscribe to these particular alerts, okay? So you're going to get some recommended alerts, and then those alerts will automatically, then you would then automatically subscribe to it. With auto detect alerting, am I able to create my own detectors as needed? Yes, you are. You can manually create your own auto detecting, your own alerting specific to your organization's needs. No problem at all. Does OpenTelemetry support more than just Kubernetes? Absolutely. Yes, it does. We actually saw a quick preview of the majority of our integrations that are available out of the box. Again, Splunk is heavily invested in OpenTelemetry. We want to make sure that your data is yours, specifically to you. And again, we want you just instrumenting your applications one time, right? Using a given observability standard. All right, it looks like the other questions, let me see if we have anything else. Well, it looks like we've gotten most of our questions answered. If we didn't get to your question, we'll definitely be sending a follow-up email to you. I really appreciate everyone for coming to today's Tech Talk. It was a very exciting one. And I really do appreciate your time here. I want to thank you once again and have a great day. Thank you, everyone.